Today in this video we are going to set up this little 3018 CNC router, and we're going to use free programs. But the first thing to do is to connect the machine app so we know it's going to be live, and plug it into the computer, and then we will install the driver. So I'm going to show you a few tips and tricks now to get this little 3018 CNC router up and running. Now, the supplier who supplied this machine to me, who was based in Australia actually, so this machine was already in Australia, and I purchased it off eBay Australia, that is. Now, the compact disc that it came with, little mini compact disc, I checked it over and the programs on it were absolutely fine. So I've downloaded Grbl, which is the operating program that runs the machine, that administers the G-code then, like Mac 3, was fine. But if you wanted to go to the website to directly download that program from, it's from GitHub, which is here. So you come into GitHub and you sign up with GitHub. Now it's a free program, all right? And you scroll down through their listing and you go to the latest version of Grbl and download that if you wish. Also, my recommendation then would be to go to the Inventables website and download. You sign up with them as well. It's free. And this is Easel. This again is a CAD-CAM program. It's a simple CAD-CAM program that you can do your design work in here, as in shapes, lines, and also lettering and things like that. And this will write the G-code. So it's a CAD and CAM, simple CAD-CAM program. It will also do 2.5D shapes and things like that. 3D work, not quite sure. Don't know whether it's a powerful enough program, but we will find it in the future. So, for a free program, this is my recommendation to start off with. So you can actually get to start to learn how to simple program, transfer it into the little router via Grbl. We will actually carry out a simple drawing or lettering, and we will write the G-code, store it, save it, then put it into Grbl and run the machine. But before we do all that, we need to get the computer talking to this little CNC router. Before we do that, I just want to take you through to, first of all, now this is Banggood, okay? This is Banggood, Australia. I just want to show you an interesting thing that's happened over the last couple of days since I released the first 3 videos that I've made on this particular build. Here's a similar machine. It is not the supplier that I purchased from. price for the basic little router has jumped up to 406 Australian dollars. That's not with the laser. Further down, here's one with laser, but it's only a 500 milliwatt, so that's a half a watt little laser. Okay, that's okay because you can actually buy a larger module, but obviously it's going to cost you more. And don't forget, these are Australian dollars, which is worth about 70 US cents, I think, is the conversion rate at the moment. Anyway, what I'm trying to tell you is it pays to shop around, because here's one, okay, with the 5500, which is 5.5 watt laser. Now, this is the identical machine that I got. The price has doubled in 2 days. Okay, it's now 675. I paid 350. Okay, for the CNC router and laser machine. I'm showing you this because I don't think it's very fair, if you know what I mean. But if you shop around, you know, you can get them an awful lot cheaper. And I don't know about too much about the plastic framed ones. I don't know too much of them at all. These are a very similar type of unit, but well, actually that's a lot smaller. Anyway, that's bang good. Same on Gearbest. They've jacked their prices up too. So what I'm just checking the prices again. So eBay Australia. Here we go. The prices have gone up slightly, but they're still fairly reasonable. Let me see. Another one here. See, look at this. Okay, here we go. Let's go in and have a look at this one. Okay, so this one, you need to choose the model and what you want with it. So the model is a CNC 3018, and choose the laser with it, which is 550 watts. There's the US price. Okay, which is 291, which is similar price to what I paid. Okay, that is with freight. Okay, so you can still get them. And this is the model I purchased, but not the seller. Okay, this is just the model I purchased. So I thought I'd show you that as a matter of interest. Okay, so we'll get out of that for now. Oh, incidentally, another way of getting the free Grbl program is if you go on any of the ones in Banggood, and you come down to software download, click here, hopefully, and it's just a drop box, and you can get the driver here. Okay, and I won't click on it because I already have it, and Grbl control you can download here, so it's available from this drop box as well on Banggood. I think it's also Gearbest is available too. So there's several different places where you can actually get the Grbl program from. Okay, so I'm on this laptop computer now. So I've just changed. So this is the computer that is running the 318 router. So we're going to open up Grbl. Okay. So you'll see here the Grbl control is here. The Grbl laser control is here. It's a separate program. Okay. They also give you some test codes. We'll actually use one of those now. We'll just do a little test with that. And there's a manual. So what we're going to do is open up Grbl. Now there's the driver. Okay, so it's the CH340 SER. That's the driver that speaks to the Arduino. All right, so it allows the computer and the Arduino board that runs the CNC router to talk to each other. Grbl software instructions, and this is the software itself. So we'll open the software. It's already put into my computer. So we'll open it. And there it is. So this is Grbl control. Very similar to Mach 3, but it's much simpler. So we've got to see if they're talking. They should be talking to each other, but just to start you off right from the very beginning, you need to tell your computer which port or which COM drive this is on. So you connect them together. That's very easily done. Don't forget, prior to this you would have put the driver in. Alright? So you come up here to Service, press that, Settings, okay, COM 3, and I know that it's on, this is actually on COM 3, I know that. Yeah, there you go. So, and really that's all you need to do, to tell or let the computer talk to the little router, COM 3. So we know it's on COM 3. If you're having trouble finding which COM your router is connected via the computer, just go into Device Manager, go into Ports, COM and LPT, expand that, and you'll find it here. Okay, so it's in serial port, so it's in USB serial port, CH340, that's the driver, okay, and it's in COM 3. So you put COM 3 in to Grbl control, like I just showed you just now, okay? That number there relates to the Arduino board. Now this is units, so I work in millimeters, so we'll leave it in millimeters. Now this is right, rapid speed. Now this is millimeters per minute, okay? Acceleration. The acceleration here, 100, it's not a representation of time or percentage. It's just a number. Okay, now we're going to play around with that in other videos, but to get this started, we're going to leave that as it is. Now this one here, this line here, minimum 0, maximum 1000, this relates to the RPM of the little motor that actually does the cutting, the little rotor itself, or spindle, whichever way you want to call it. Now the motor, I know, will run at 7,000 RPM offload. Okay, that's when it's running free but flat out. So that 1,000 represents 7,000. Okay, and so what it's saying is, well, there's 1,000 divisions, okay, between 0 and 1,000 that you can actually set it to. But in fact I think there's about 10. But we'll play around with those again. It's just minimum and maximum. It's just a number that the program understands whether you want me to go faster or slower. Okay? And this one here, 0 to 255, now that represents the laser. That is, I suppose if you looked at it as a grayscale, there's 255 colours of grey from white to black. So if you can look at it like that, it's a power level. Okay, from burning black to nothing, white. So that's what that represents. These numbers you really don't need to worry about. This is G code and nothing to worry about. So this is really to get us going. That's all we need. That's all we need to check. Okay? So we're going to press OK. Now we're going to see whether this is talking to the computer and whether it works. Okay, so now is the time to see whether it all works, I suppose. Okay, so here we go. Okay, keep your fingers crossed. So, and these arrow buttons down here, okay, will move the machine X, Y and Z axes. Now if I scroll down, now you can either move the axes by setting an amount, 1mm, 5mm, 10, 100mm, or fractions of millimeters. Well, I'm going to have it on continuous, so that means while I have my cursor on the arrow, it's going to move. So where shall I put it? Somewhere else, alright, I will have another camera showing the little router moving, hopefully. So hopefully we're going to go that way. Look at that. And back. Very slowly. We got the feed rate set at 555 millimeters per minute. Now let's go. Was it forward? So that means the rotor head's going backwards. That's correct. And going forwards. And up. And down. So we got all movement. Oh, I heard a little squeak there. It's maybe a little dry. So that's one thing we're going to have to do too, and I'll show you how to lubricate all this up properly. Okay, so what we're going to do, okay, now to enable the keys on the computer to operate the machine, in other words the arrows on the numerical part of the keyboard, we're going to tick this box here. Okay, now let's see if that works. So that's, yep. Up, down, yep, that all works. So it works fine. So everything is talking to each other. Now the next thing is the spindle. So here's the spindle. So we'll set it. Oh, here we go. It's turning on. Move it down slightly. Well, it works. I don't know why that slide isn't working. It's set at 400. Okay, I just found out something interesting. There might be a key on the keyboard. When you have keyboard control ticked, you can't actually alter this. When you untick it, you can. And just to prove that we can, so that's 100, whatever that represents. Maximum. So it does work. I mean, it does work on the slider and what have you, but when you have the key panel control ticked, it doesn't. So there must be a two keys on the keyboard that that operates that. I'll work it out. Okay, I do notice on the internet a lot of people complaining that when they have connect this up, the X, Y and Z movements actually operate in reverse. Now I'll show you how to put that right. I mean, mine is perfect, but so if I just drop this down a second. Now this is the manual of Grbl control, which you can download. Now if your machine is operating in reverse, you don't have to change any wires. This is, I wouldn't say a normal situation, but it's quite a common situation, and it's very easily fixed in the program. So what you need to do, now this is Grbl code then, similar to G code, but this is Grbl code, and what you need to do is write in let me see, step in direction, step, direction, invert, alright? Invert, limit pins, okay. So what you would have to do, you would need to write in $, I'll show you where to write it in. So get that down, pull that up. See this control here, this little box here, you write in there, I won't do it because mine's fine, $3 equals 5, okay? dollar, so it's dollar sign, dollar, 3 equals 5. You put that in, press enter, and it will invert the control. Okay, so then you should be right. Alright, so don't go, there's no need to go pulling wires out. You can actually do it in the program. Okay, so it's dollar, 3 equals 5, and I wish my phone shut up. Okay, so we've established now that it's working. It's a bit long-winded, but I like to show you everything, and that it is really easy. It's not. Don't like to use the phrase it's not rocket science, but it really isn't. It's fairly simple. So we've got it working. So I suppose we'll give it something to do now. Well, first of all, I do see a lot of people. It's very rarely, actually, I've seen anybody put a piece of material on here, on the table, correctly. I'll show you the correct way. Okay, let's see if I can do this without getting my head in the way. I've got a piece of oak here. See if it bites into that all right. Now, these are the tie-down clamps that they sent. These little screws are ones that I've put in there, actually. So this is the correct way to do this. Okay, so you have your bolt and your wing nut, and this is your clamping mechanism. This is what puts some force down on it to hold it. So you put that, slide that one in there like that. So the tip is just touching. Then you get a scrap piece of wood and put under here. And just till you start to make a little bit of contact. Okay, this needs to be flat-ish. Okay, so now you tighten this up. So you, more fingers and thumbs. So you tighten this up. Okay, just nip it there. But this is where you put the force on it. Okay, that's quite tight. That's about as tight as you need to be. It's not going to move anywhere. The only thing you've got to be worried about is coming into contact with these with your tool. Okay? So that's the next thing. Now we're going to put a tool in here. Now this is a little ER11 collet. Hang on. Let's get a... And with mine, they sent me some little spanners too. So we'll just get one on there. And one on there. And have a look at the collet that's in there. Oh, look at that. It's beautiful. And that's a collet. That's a 1/8 of an inch collet, actually. That's what it's got written on, the 1/8 of an inch, which is roughly about 3 millimeters. So we'll get a cutter now. Okay. This is the one of the ones that they supplied. Now, this is an engraving bit. Now these are very, very sharp. So what you need to do is pop it in there like that. Hope you can see this, because my fingers are all in the way there. And nip it up nice and firm, but not too tight. Okay, just firm like that, that's all it needs. It's only a little baby motor after all. Then, so we've got the tool set, and what we're going to do now is write a little program in Easel and transfer it into Grbl. Okay, so when you start using Easel, you will need to set a few parameters. So you go into Machine. So this is automatically set up for Xcarve. So other Grbl. Probably not listed here. Yes, it is. There it is. Okay, and work area. Well, the work area is 300 by 180. Spindle control manual, spindle control is automatic, and it's 7,000 RPM. Well, actually I'm just going to put this down to 1,000 because that is the number, if you remember, that was set up 0 to 1,000. So I'm going to put 1,000 here because we want it going at maximum RPM for that little machine. Okay. I think this is going to tell me that I can run the machine directly from this program, but I don't want to do that, so I'm going to leave that as it is. Workpiece. So we'll set this up, and the workpiece is, let me see, in the X it's 100. And in the Y it's 40. And it is, I'm going to say it's 5 millimeters thick. Okay. So you can pan around and zoom and what have you. It's actually not in this bottom corner there in relation to the table. I'm not sure how to move it to the center of the table. I don't think I have to worry too much about that actually. So what we're going to do, we're just going to do some text. Okay, I've played around with the lettering a little bit and altered the depth of cut to 2 millimeters, and I chose a very pointy tool, this one here, and suddenly the lettering appeared, so I worked that bit out. So let's do a simulation now. Let's have a look. Okay, that's much better. So now I'm going to send that G-code to my desktop, and we'll load it into Grbl. Quite simply, I actually did this very quickly. Load it. What I actually did was go into File, Open File, and there it is there, and it's in. It's as simple as that. Now what we need to do is to set up the 00 of the tool. So what I'm going to do is, in this area here somewhere, I'm going to put in the view from the second camera of the cutter, and I'm going to set up the 00, okay, of the tool. Now I'll use the button controls on here rather than the keyboard controls on the computer. So we're going to set the Z down. I think we're going to go to 500, and we're going to go to 0.1. I can actually see the point just going into the material there. So we're going to call that right. So to Z0 is this one. You notice it changes to Z0, and the XY is this one, and then that gives us, I don't know why it goes +1 there. I don't think that really matters. So we're going to go continuous, and do you know what, just to be safe, I'm going to raise it up. I'm going to trick it. I'm going to air cut first. So let's Z0 that, 00, and we're going to call that 0, and I'm going to run this program just to see if now the motor turns on automatically. I'll take that up there. See if that turns on automatically, and just to see if it's going to do what we think it's going to do. So I shall raise that up, okay, as though I would do normally. And now to make this run, we press send. Obviously to stop it, press pause or abort. Let's see what happens. Error message. Oh, also don't show that again, ignore it. I was getting into it. It'll certainly get into it alright for a little tiny router. I mean, alright, we're air cutting. I'll let it go through the full process. Oh, look at that. Who needs Mac 3? It's absolutely ripping into it. I mean, alright, we're only air cutting at the moment, but my word, it's really going for it. I'm leaving this run in real time. I mean, it's just interesting to see. You know, it's actually cutting it not as fast as my big router, but you know, it's surprisingly quick. I can actually see that the cutter is running slightly eccentric. Slightly blurry there. What I'm going to actually do is I'm going to let this finish. I'm going to reposition the cutter in the collet. So I just think that because I can see it's a little blurry, which means it's running a little bit eccentric. Job done. Okay, thank you very much. Okay, I've repositioned the cutter in the collet. I've repositioned the cutter in the collet now, and it seems to be running a little truer. So I'm now going to reset the zero. So we'll come down, and we're going to set this at, there's my head's in the way. Instead of continuous, we're going to go 1 millimeter. Oh. Let's go to 0.1. I'll say that's good. And we're going to zero the Z. You can see I've pushed it in a little bit further by the amount of. Okay, so now we're going to alter this back to continuous, and we're going to raise it up. Now this time we're going to be cutting wood. I'll probably swap the cameras around now, and I'll put on the big screen, I'll put the close-up of the tool cutting, and the smaller screen I shall put Grbl running the code. So here we go, we press send and off we go. Too bad, not bad, but I think that there's a better tool, better cutter to do that with, and that's this one. Okay, let's just reset this a little bit higher maybe. Right. I want to give it a bit of a chance here. So I've set the XY and I've set the Z0. I'm going to raise it, let's put this to continuous, raise it up. Let's give it another shot into MDF. Not deep enough. Okay, so we'll abort that one and reset. And we're going to take the Z down. Let me see. Half a millimetre, I think that is. That's half a millimetre. Set the Z0 again. Put this to that, raise him up. It's quite fun playing with this actually. What happens if I start with the tool right it is there now? Let's see. No, still not deep enough. Being a little bit So before, reset, set this to 0.1. Oh. Okay. See what happens there. Another 0.4. Set the 0. And that's better. Okay, this time we're going to try a little 1.5mm ball mill. See what it makes of it. Okay, we're going to call that good there. So we'll 0 that one, put it back on continuous, raise it up. I got that a little bit slow. Okay, so reset and let's run this one. Well, for a first attempt, it's not bad. This is with the that very sharp cutter. This is the little 1.5 ball mill, 1.5mm ball mill. It's gonna cut it okay. That was a total waste of time, but you know, it will do it. It's just a matter of getting used to it. But what I'm finding, obviously the sharper the tool, you know, the sharper the tool going into harder wood, I mean, the better off you are. And you know, that last cut in the MDF, you know, I did with the 1.5mm ball mill. It was okay, but you know, it's the first time I've used it. So, but I can see some faults now. Already, I can see some limitations. Actual fact, I'll just refocus the camera and I'll show you one limitation that needs to be put right. Not in the short term, but in the longer term, because I need to finish, you know, sort of doing experimentation with it to find out, well, exactly what we can do to make it a better machine. But I'll just show you one thing now. And I already half knew this, that the flex, see this flexing? I mean, you can do it with one finger. And it flexes, you know, 1.5 mm. So that's a serious sort of problem with it. And the other problem, which I already knew, is this motor just is not man enough to push the tool. It's not man enough to spin the tool. It hasn't got enough torque. But having said that, it's not a bad little CNC router. If you want to learn how to use a CNC router and use the CAD-CAM programs like Easel and, you know, this program Grbl to run the machine, how to alter things, running of it, you know, the speeds and the what have you. You saw me live doing it. It's the first time I've ever used this program. It's not hard. It's a good starter. You know, $350 or so. Like I showed you earlier, the prices are going up. I don't know why they're suddenly going up. Do you? But they're a good start, and I don't see any reason why you should have to pay more than, you know, 350 to 400 Australian dollars for the laser and the CNC router part of this. So shop around. They're on all the major outlets, you know, eBay America, Europe. I bought mine from eBay Australia, so this was already in Australia. So it wasn't shipped in from China. Banggood, Gearbest, Amazon have them. And I dare say if you went onto Alibaba, you might be able to get one for a good price there as well. So, you know, there's many different outlets that you can buy these from, and there's many different manufacturers. I don't even know the manufacturer of this machine. I bought it from a seller, an online seller on eBay, you know. So, and I see too in the comments section that people are asking me, what about the black ones, or is this a pro? I think this is a standard machine, but it's a pretty good standard machine. You know, you can generally tell whether it's a better machine or not. Whether if this is injection molded, I'd say it's a better machine. And you can normally tell if you zoom in onto the photographs that they got showing the photograph, showing the machine. If you can see the build lines, well, you know it's 3D printed. There's not much wrong with 3D printing parts, so long as, like for this, they would use ABS, not PLA. ABS will withstand the motor heat a bit better. Because when you run these, you run them for hours on a time, especially if you're doing 3D machining. So I'm going to play around with this a little bit and see what else I can do with it. I'll see what other faults I can find. I mean, I've got some idea of what I'm going to do anyway. So I'm going to run this a little bit more for a couple of days. I might do another video running the little rotor head motor, you know, seeing what else it can do, whether I can do a 3D cut with it. Don't think very much, not much of one anyway. And you know, I'll see what I can come up with, and you know, I'll do another dedicated video for the laser module on this and see what we can do with the laser. But you know, that'll come in time, and then we'll work out exactly, as I say, what we're going to do to make things a lot better. So thank you for joining me, and I hope you've enjoyed these last couple of videos of building this up and now giving it a bit of a test drive and finding out very early what some of its limitations are. And if you have, please press like and subscribe, and if you wanted to help support this channel, you could pop along to Patreon and become a patron. Whatever I design for this, all the drawings and the STL files, if you know, for 3D printing and whatever, will be on my Patreon pages. And please don't forget to subscribe to the channel and pass it on. Pass the videos on and help the channel grow. So thank you for joining me, and it's bye for now.